Good evening, everyone. Welcome to this presentation by Gurukulplex, where we explore the fascinating laws of physics and investigate the mysteries of the universe. Let us embark on this journey together and discover the incredible scope of what can be achieved with just a basic understanding of the physics that govern our everyday lives. So, without further ado, let's begin. Exploring the universe and its many secrets highlights the importance of understanding the laws of physics that affect our everyday lives. From how we move and interact with our environment to the technology that helps us with our work, play and connections, these laws affect us in numerous ways. The laws of physics apply to all things in the universe, from the tiny subatomic particles to the largest structures. Enhancing our knowledge of these laws can assist in unlocking the secrets of the cosmos and extend the limits of what we can achieve. Come along with me on this journey as we explore the fascinating world of physics and discover the mysteries of the universe. An object at rest will remain at rest until an external force acts on it, which is the basis of Newton's first law of motion. The force applied to an object is proportional to its acceleration, as defined by the second law of motion, and for every action there is an equal and opposite reaction, as per Newton's third law of motion. For example, when a person pushes a shopping cart, the person's force causes the cart to move due to the first law, and the force applied by the person and the cart's acceleration are related by the second law. Finally, the third law explains why the person feels a force pushing back on them as they push the cart forward. To further explore these laws and more, Gurukulplex presents an informative presentation. Gravity is a powerful force that influences all aspects of our lives. It has an integral role in the laws of motion, and it works to bind the universe together. Though it is typically associated with objects being drawn to the ground, Newton's law of gravitation explains that it is a force between any two material objects. This force increases with the mass of the objects and the distance between them. We observe its effects in our everyday lives as objects move towards the ground and stay at a constant velocity unless an external force like gravity acts on it. Gravity is a fundamental part of understanding the universe. Energy and work are intertwined by the laws of physics. To understand the physical world, it is essential to comprehend how these two concepts interact. Work can be described as the exertion of force over a range, and energy is the capability to do work. Examples of this connection can be seen in everyday life, such as when we lift a heavy object, the more energy used, the more work done. There are multiple forms of energy, for example thermal, potential, electromagnetic and kinetic energy, which can be changed from one kind to another. By understanding the relationship between energy and work, we can gain a more profound understanding of the basic principles of physics. Thermodynamics is an absorbing field of physics that allows us to comprehend how our physical environment works. The regulations of thermodynamics are vital in comprehending how energy transforms form and how it is conveyed from hotter bodies to cooler ones. The first law, also known as the law of conservation of energy, asserts that energy cannot be made or obliterated, only swapped from one form to another. The second law claims that the totality of entropy of a sealed system always rises over time. And the third law states that it is impractical to reach total zero. All these laws are indispensable in understanding how the universe works and have numerous practical uses in our day-to-day lives. Heat transfer is a complex phenomenon that is essential to the workings of the universe. It is the process through which energy is exchanged between two or more objects. There are three distinct methods of heat transfer: conduction, convection, and radiation, each with its own unique properties. Conduction occurs when heat is transferred through a solid material such as a metal rod, convection when it travels through a fluid such as air or water, and radiation when it is transferred through electromagnetic waves, such as those emitted by the sun. The laws of thermodynamics, which govern heat transfer, enable us to understand the complex processes of energy conversion and transfer in the universe. Good morning. Entropy is a concept that has been used in thermodynamics to describe the amount of energy in a system that is no longer useful. It is often associated with confusion and disorder, but in this context, it actually speaks to the transformation of energy from one form to another. A real-world example of this can be seen in the burning of fossil fuels. When gasoline is burned in a car engine, only a portion of the energy is used to power the car, while the remaining energy is lost as heat. This heat then contributes to the overall increase in entropy in the universe. Thank you. Electromagnetism is one of the four fundamental forces of nature, governing the behavior of electrically charged particles. From the behavior of atoms to the way light travels through space, its effects are everywhere. James Clerk Maxwell first described the laws of electromagnetism in the 19th century, introducing the concept of electric and magnetic fields that can generate each other. This idea led to the creation of electromagnetic theory, which has been a great boon in unlocking the secrets of the universe. Electricity and magnetism are fundamental elements underlying the laws of physics and the mysteries of the universe. Electromagnetism is the phenomenon by which these two forces act in concert to bring about a variety of effects. A prime example is the electric motor, which utilizes an electric current to produce a magnetic field, and another magnetic field to generate motion. This same principle is employed in transformers and generators, demonstrating the substantial influence of the bond between electricity and magnetism. Light as an integral part of our universe and its behavior, or optics, is key to physics. The laws of physics are used to comprehend the effects of light interacting with matter, from its movement to its reflection and refraction from surfaces. Comprehending these laws is necessary to support the development of novel technologies and to progress our understanding of the physical world. Light is a captivating part of our environment. Reflection is the process of the light bouncing off a surface, and refraction when the light passes through a material of different refractive index, causing the light to bend and creating a new angle. Comprehending the laws of physics has enabled us to grasp the behaviors of light and how it interacts with its environment. Sound and waves are an integral part of our daily lives, from the sound of our voices in music we listen to the natural phenomena such as echoes and resonance. Investigating these sounds and waves is of great importance to physics, providing greater understanding of their behavior and the energy transmission through different mediums. Studying sound and waves can offer insight into the laws of physics and the mysteries of the universe. Such research could then lead to practical applications in architecture and engineering, such as in the design of sound systems and devices. We can use the laws of physics to uncover mysteries of the universe that may have seemed impossible to fathom without them. Wave properties, such as wavelength, frequency, amplitude, phase and polarization, are an integral part of physics, and we can use them to better understand the behavior of light, sound, and other phenomena. Through such understanding, we can begin to unlock the secrets of the universe. Quantum mechanics is a branch of physics which has profoundly impacted our comprehension of the universe. It has enabled us to delve further into the behavior of matter and energy, providing novel opportunities and progress in technology. At the core of understanding quantum mechanics lies wave-particle duality, referring to the fact that particles can demonstrate both wave-like and particle-like properties. This has altered the way we view the universe and has aided the discovery of various secrets. The exploration of physics and the universe leads us to the very center of matter. Atoms are the basis of all material, constituted by three kinds of subatomic particles: protons, neutrons, and electrons. Protons and neutrons are located in the nucleus of the atom, and electrons circle the nucleus in shells or energy orbits. Each element is determined by the number of protons in its nucleus, known as its atomic number. This number also has an effect on the setup of the electrons in its orbits, endowing each element with its distinct chemical properties. Nuclear physics is a field of study involving the exploration of atomic nuclei and their behavior and properties. This includes delving into the strong force that binds particles together and the weak force that affects the decay of unstable particles. With nuclear energy being a potential source of clean energy, the comprehension of nuclear physics has taken on a whole new level of significance in recent years. Consequently, it is an area of research with promising prospects for the future. Albert Einstein's theory of relativity is one of the most groundbreaking scientific theories ever, transforming our knowledge of space, time and gravity and influencing modern physics greatly. It is based on the concept that no matter the relative velocities of two observers, the laws of physics persist for everybody, meaning everyone will witness the same physical events the same way, though differences in time and space can be experienced depending on their speed of movement. Such is the power of relativity. Physics has been a fascination for humans throughout the centuries, and a major leap in understanding it occurred in the early 1900s with the development of Albert Einstein's theory of general relativity. This revolutionary approach revolutionized our comprehension of gravity, introducing the concept of light bending around massive objects, which was famously recorded during a solar eclipse in 1919. In addition, it also provided insight into mysterious occurrences such as black holes and the enlargement of the universe. This presentation from Gurukulplex looks into the laws of physics as well as the puzzles of the universe. The Big Bang Theory has been the most widely accepted scientific theory describing the origin of the universe. It proposes that the universe began from an incredibly compact point of matter and energy that then rapidly expanded. This expansion can still be observed today in the form of distant galaxies and their respective redshifts. There is a plethora of scientific evidence that bolsters this theory, such as the cosmic microwave background radiation, which is believed to be a remnant of the early universe. It is without a doubt that the Big Bang Theory is a remarkable and awe-inspiring explanation for the mysteries of the universe. It has been a great journey exploring the fundamental laws of physics and the mysteries of the universe. We have seen how these laws shape everything around us, from the smallest particles to the largest structures in the cosmos, and how understanding these laws is essential for advancing our knowledge of the world and developing new technologies that can improve our lives. We are now equipped to tackle any challenges that come our way, and marvel at the complexity and beauty of the universe. Thank you for your attention.